Okay, we are up and rolling. Okay, to start out with today, I'm going to do a flashback. And just to signify that it is a flashback, I'm putting this beautiful little lightning bolt. Then I'm going to put flashback. Yes? Okay. Now, when we start working with transformations and we're looking at the math behind them, we are going to use the coordinate plane as our way to organize what's happening. Now, just to flash back here, we've got our coordinate plane, and I know you've done this before. We have our y-axis and our x-axis. And just like with Miss Pac-Man, they stuck the coordinate plane over the screen so that we could get a little bit more precise on how we were watching her movements. Coordinate planes are great for this. You used it in science class when you were graphing what happened when something went from a solid to a gas, right? You were able to organize your information so that you could actually use it. And that's one of the nice things about coordinate planes. Now, when you first started working with a coordinate plane, you started working in quadrant 1. And there are 4 quadrants for every coordinate plane. But when you first started working with it, your teacher in elementary school only introduced this part. Why do you think you only started with quadrant 1? It's the beginning one. Why is it the beginning one? Why is it a great one to begin with?
Because it's one.
It is the easiest. Why is it the easiest?
Because it's both positive.
It's both positive numbers. The x and the y values are both positive. Now, when you're graphing points, when I say x and y, coordinate points are always listed in this order. And it doesn't matter where you go across the world, the coordinate plane is the exact same. Your x value is first, and then your y value. So when your teachers were teaching you this, you would go over to the x, and then you would go up to the y, and they knew that you were working with positive numbers, and you were strengthening your skills for coordinate planes.
I got a good way of remembering it. You have to go over to the tree before you climb it.
Okay? Or if you, now that we have negative numbers, we have to go over to the elevator, whether it's left or right, before we can go up or down. Okay? Now the weird thing about the coordinate plane is when we go to numbering the rest of the quadrants, we go counterclockwise. Quadrant 2 is over here. And then we go down here to quadrant 3, and then here is quadrant 4. The other thing that's a little bit different is quadrants are always labeled in Roman numerals. We have quadrant 1, 2, 3, and 4, but they're always labeled in Roman numerals.
Or 4.
Okay. Quadrant 2, my points are negative for the x and positive for the y. Quadrant 3, what kind of points do I have there?
Negative, negative.
Negative, negative. And quadrant 4, I would have
Positive, negative.
positive, negative. I go over to the x, but then I have to go down to find that y. Okay, so this is what we're going to base our transformations on. And we're going to get very, very precise as we continue moving through this unit. But right now, all we need to do is, based on our problem that we started class with, you really didn't know where I started with and where I ended and what I really wanted you to do to get there. So what we're going to do is we're going to put some words and we're going to put some labels with this. The first thing we're going to learn is that the very first image, whether I draw it or whether you draw it, is called the pre-image. So the first shape, the first image, the first whatever it is known as the pre-image. Now, I do apologize for this block letter T, but we're going to try to put this, and I'm going to try to draw it a little bit bigger because we drew it so small last hour, it was hard. Oh yeah, I'm going to make this really big.
With white plastic.
Okay, that is a horrible looking rendition of what I drew on the board, but it'll be okay. Now, some of you thought that I translated it over. So while I'm drawing this, I'm just going to translate it over here real quick since we're in the drawing mode. Oh, yeah, that is just not a great looking example, but it'll do.
It looks just the same.
Thanks, but it really doesn't. Okay. Now, you all remember which one we drew first, right? We drew this guy first.
Yeah.
He is our pre-image. Unfortunately, he has a lot of points. I'm not going to label every point. I'm just going to label enough so you can kind of see what happens. I'm going to label this point here A, this one B, and that one C. The pre-image points are just labeled with letters. That's how you know it's the pre-image. So my pre-image is just A, B, C. That's where I started. Now, what did I say I did? I translated it. So I'm just going to write what happened here. I translated ABC to the left. Now, we'll get even more precise as we move on, but I'm just going to say this for now. We translated it to the left. Now we have to label our translation. Okay, now can everyone see what happened in their brain as we translated it?
Yeah.
Okay, so where is A?
I know.
Is A right here?
Yes.
No, it's on the left.
I translated it so it would have to be here. Now this is how you write down that something's happened to it. I'm no longer with my first shape, with my pre-image. I now have an image of what I just did. We put just a little prime. It's just like this little comma floating behind it. It tells us, hey, something happened. And then I'm going to do the same thing for B. B's over here, so I'm going to put B prime. And then where would C prime be?
On the other right there.
On the y-axis there. Now, you know what? I probably wouldn't even have had to have told you that I translated it. You probably could have looked at this and said, oh, that was a translation. The A stayed in the same place. The B stayed in the same place. They were just slid over. When we get our image, that's our second shape, that's when we label it with the primes. Because we know something happened to it. It may not have told us, but we know something happened. It was transformed because now we're at the image. We're at A prime, B prime, C prime. Here's where we started, A, B, and C. Okay, now let's go to a reflection. Let's try to reflect this guy. I'm using my lines as a guide. I will tell you though, making this a much bigger blocked T makes this a whole lot easier than what I did last hour. Okay, so what did we do? We reflected over the, which axis did we reflect it over? We reflected it over the x-axis. Okay, so what we basically just did is we knew we had a reflection and we're telling everybody else, hey, you got to reflect it over the x-axis. That's the mirror. With Miss Pac-Man, it was hard to figure out where she was reflected over. She kind of reflected over herself, okay? And by the end of the hour today, we're going to actually be able to, if it's not the x or the y-axis, we're going to actually be able to figure out what line it is. What line is the mirror? Okay. Where does A go now?
Oh,
Is he right here?
No.
no, he's on
Here.
the other side.
No.
No,
Here?
Yeah.
no, that's B.
I'm
That's A.
reflecting it.
No, it's A.
No, that's
This
A.
is A.
Hot.
And it's going to have 2 primes now. This is the second transformation I just did to this shape. I first translated it. That was the first transformation, so I put 1 little prime. Now I've reflected it, so it's 2 steps away from where I began.
It makes kind of those number signs on the telephone because like on the first one it can reflect out the next one.
Oh, yeah. Yes. And, oh boy, where's C? Is it this top one here or this one here?
Bottom one.
The bottom one? Okay. And 2 little primes. And I've learned that my marker has to dry before you can see them. Okay, so now you know not only what these are, here's my pre-image, here's an image, and here's an image, but you now know how to put the notations or the symbols with it so you can communicate to other people what has been happening. Because I bet I could have covered this up and some of you would have been able to figure out, okay, if we started here, how did we get here and how did we get here? Based on the labels, just the labels. Okay, we're going to leave this example now and we're going to just move to rotations. I'm not going to try to rotate that baby on there. We've got way too much stuff. So I'm just going to do simple rotations here. We're just going to do a triangle. And I'm going to name the triangle KSU. Now remember when we were talking about earlier, we can have that point of rotation be anywhere. So I think what I'm going to do is I'm going to put the point of rotation here at the U. So it's like I'm hammering in a nail, and now this triangle is only going to rotate around that point. Let's see. Let's do a 90-degree rotation. And I learned this last hour. If I don't tell you what direction, you all start going 90 degrees in 2 different directions. I'm going to say clockwise. So I want to rotate triangle KSU 90 degrees clockwise. So now I'm going to visualize this. This one I can do. And it's going to end up being like this.
Whoa.
I know. Is that what you were thinking it was going to look like?
No.
I rotated it 90 degrees. Now I've got to figure out where is the K and where's the S and the U.
I know.
What's this point right up here that's now,
S.
that one's the S. So I would label it how?
S.
Prime.
Fine.
S prime. And what is this point over here?
B.
That's the K prime.
And then you
That's so cool.
And I'm rotating it on U, so U,
Is U.
U, yeah, U prime.
Prime.
What would have happened if I would have taken the same triangle, KSU, let's see.
Rotated it from the K.
Nope, I'm going to put my point of rotation smack dab in the middle of the triangle. And, oh, we need to know how far we're rotating this. I'm going to rotate this guy
20.
180 degrees rotation. Now, here's the thing about 180 degrees. Do I really have to tell you which direction?
No.
Yes.
No.
If I go clockwise or counterclockwise?
Sure. Why not?
Will you still land up at the same spot? We'll still land up at the same spot. Okay, this one's going to be hard to draw. Let me eyeball where we're going to be. And I'm going to draw it with dotted lines. So we can kind of
Whoa.
see. Oh, that kind of ended up looking like an arrowhead there. I kind of went down.
Kind of cool. Didn't like that.
Okay. So I rotated it around the turning point, which was in the middle of the triangle. And now I got to figure out where in the world my KSU just went. Let's start over here.
K
USK.
went down at the bottom.
Oh, the K went down at the bottom. That's an easy one.
Yeah.
Now, I'm going to name this one K prime because I'm still going back to my pre-image.
Wait,
So yeah, what's this one here?
Oh, that is the
S.
S. That's
No, it'd
the
be
S.
the U.
That's
No,
the
it's
S.
the S.
No,
That's the S.
Yes, it is.
You guys are good with seeing this in your minds. You're rotating it and visualizing it. And now we are going to have the U over here.
Yeah, I just turned my head.
Okay.
Have a look.
Okay, so rotations are kind of difficult. We're going to save them kind of to the end to really get to analyzing them. But as long as you can see what they look like with shapes, we're good for right now. Okay, now I ran out of room. So if you still have room, you can continue. But I'm going to talk about reflections. And I need to get a new piece of paper going here. So also, if you know of anybody that was not here today, is Gunnar back?
No.
Okay, he would be a prime example. This will be great. I will put this in the live binder.
You just did a math
He
pun.
must be like at a vacation.
Yeah, I don't know. I didn't get where he
Miss
was
McCabe,
going.
You just did a math pun. You
I
said-
missed my math pun. What
you
did I
said
say?
Prime.
That would have been even funnier if we were talking about prime numbers. Okay. 4 reflections. You guys all know that they are flips. But we have to flip them over something. There has to be that line that they flip over. And if the line is the x-axis or if it is the y-axis, it's great. Those lines are already there. Sometimes those lines are not drawn though. So let's look at an example. Oh, that wasn't a very good. Didn't eyeball the middle of that thing really well, did I? You know what? I'm going to put hatch marks on my coordinate plane as well because I need them to guide me. Since we don't have graph paper, let's see. I am going to, this is going to be my line that I want to reflect over. That's going to be my mirror. Right there. Right here. This is my mirror. Maybe I should show on here. Right here. This is my mirror. So maybe we need a shape so we can kind of see what happens. Let's put a shape. Let's put something easy.
How about a square?
Let's put a square. I'm good with a square.
Yay. What?
Just a little square. Notice how I kind of matched him to the hatch marks. I made him only 1 unit away from the y-axis, and then I only put him 1 unit away from my mirror.
Air quotes.
Okay, and if I wanted to reflect him over my mirror line,
Air quotes.
oh, wait, we need to name him. Hang on.
How about?
W, X, Y, Z.
Aw.
Okay, oh, he's a beautiful square. Beautiful. Okay, let's see. I want to reflect him over this line that we have yet to name. We'll get him named here in a second. He's going to end up reflecting over to here. Am I right? He's a unit from the mirror, so he's a unit from the mirror. Perfect. Oh gosh. Where do my labels go
Okay,
now?
W goes over on the left hand, card down.
They all go
At the bottom?
Yes.
Y'all go in the
So
same spot.
W prime is down here. Well, I reflected him.
Oh, X
Oh,
is
you
over.
They don't go in the same spot.
Oh.
So I took this guy and I reflected him. So my W is now over here
And your X is over at the bottom.
because my W was farther away from my reflection line. So he still has to be farther away from my reflection line.
And the Z in the middle.
Okay.
And the prime.
So now, here's the problem. You know how to do it, but if you had to communicate to somebody, you need to reflect it over this line that's kind of floating off here in the middle of the coordinate plane, and they're like, huh, what line are you talking about? We need to give it a name. This is how easy it is to give a line a name. So let's go ahead and write down our notes. To
Charles.
name the lines.
Give it Charles.
The first thing you do is you ask yourself, what axis does it cross?
Bless you.
Okay? Because you're going to be creating sequences down the road, and you're going to need to know where these things are reflected over. So you ask yourself, hey, this line that's here, what axis does it cross?
The Y.
It crosses the Y.
Wrong.
Okay, remember that. I'm going to hold my finger up because I'm going to remember it crosses the y-axis. The second question you ask yourself then is where does it cross?
2.
It crosses at 2. Now look how easy this is going to be to name this line. Those two pieces of information you just got, what axis did it
Y2.
cross? It was the y. Where did it cross? It was at 2.
Y2.
Y equals 2. That's his name.
Why don't you just name it X2?
So now you can say WXYZ is reflected over y equals 2, and this is where he landed up at. I'm going to give you another reflection line. Let's test out our questions here. Should I put it in a different color?
Sure.
Let's go orange.
Good grief. You're fast.
Okay. Here's my new reflection line. If I wanted to reflect WXYZ over my orange line now,
It connected.
don't worry about where WXYZ is going to end up because you guys are pretty good at that. But what's the name of the orange line?
It's like
First of all, ask yourself, what axis does it cross?
Y2 and X.
Actually, no, what axis?
X.
Is it the y-axis or is it the x-axis?
It's the X.
He crosses the x-axis. Where does he cross at?
1. Yes, he does.
Say it louder.
-1.
Negative 1. So this line of reflection is x equals -1. So if you're like, hey, we got to take WXYZ and we got to reflect him over x equals -1, if it's not drawn in there, you can draw it in there now. Or now you at least know where it is or what its name is. X equals -1. Let's go ahead and reflect this little guy over. How many units away from the reflection line is WXYZ?
1.
He's 1 unit away from the y-axis, but is he being reflected over the y?
No.
He's being reflected over the orange. How many units is he away from the orange? 2. So he's going to have to be 2 units away from the orange line. Ooh, he's right above there. I hope I have enough room to write this down.
I sure do.
Okay.
Did it reflect just one?
No, I'm reflecting. Yeah, this is my mirror here. So what goes here at this corner?
Y. And then
W.
Mhm.
Now, is it going to be W prime or W double prime?
Double prime.
But where am I reflecting it from?
It's prime.
I'm reflecting it from the,
Y.
what is this guy called again?
A square.
He was my
First image.
first,
A
he
square.
was my first image, so he is known as the, he is known as the pre-image. So if I'm going from the pre-image, when I make this reflection, it's still only going to be 1 prime because I didn't come from this guy. I'm coming back from the pre-image. So now he's W prime. What's going to be over here? Is this, oh, that's X, yeah. And then Z is below,
W.
oh, Z is below the W. So Z has to be here. And Y is below the X. So Y prime has to be there. Okay,
Are we in?
you guys now have
Starting going.
two really good pieces of information that we're going to build on. We now know what the first image is called, the pre-image. We know what happens, what it's called when we do a transformation. It's called the, after the pre-image, it's called the,
Pre-image. Prime.
after the pre-image, it's called the
Image.
image. And we know how to label them.
Yeah.
We have to use the little prime symbols or the double prime symbols to show what in the world we're all doing with this. Okay, do not lose this. This is like the big piece of the textbook. Going into my textbook, it's going to go after the Miss Pac-Man stuff, after the 4 circle Venn diagram. So that way I have it right here in my notebook and I can refer to it whenever I need to.
Still recording.